Hello space fans and welcome to another edition of Space Fan News. Ever wonder what's going to happen to the outer planets of our solar system when the sun turns into a red giant? Will they survive or will they get flung out into space? Well, this week astronomers found some clues to these questions from observations of a white dwarf that appears to have a planet at least twice as large as the star itself. This episode is sponsored by MOVA Globes, who make these really cool ambient light powered globes that turn with no cords whatsoever. They make outstanding gifts, and they have a moon one, many planets, as well as an Earth globe as well. So check them out using the link in the description box below. These are really cool. Okay, so a group of astronomers got together and thought it'd be fun to take a close look at over 7,000 white dwarf stars that were cataloged by the Sloan Digital Sky Survey. And they looked at them using ESO's Very Large Telescope and the X-Shooter instrument, which is a medium-resolution spectrograph that is able to record light from the ultraviolet all the way to the near-infrared. And as they were looking at these stellar remnants, one of them caught their eye. It didn't look like all the rest. Why? Well, for one, it had a spectrum that contained hydrogen, oxygen, and sulfur associated with it. And this was weird because white dwarfs typically don't have those elements in their spectra. So what gives? Well, to understand these observations, let's take a step back and talk about what white dwarfs are in the first place. Now, if you've ever taken an Astronomy 101 course or gone to a star party, you've probably heard that our Sun is a G-type main sequence star, and it burns about 600 million tons of hydrogen into helium every second. Now, the Sun has been doing this for about 5 billion years, and it will be continuing to do it for another 5 billion or so more years. And at that point, though, things start to get interesting. As our Sun begins to run out of hydrogen, the core will begin to contract and become much denser and a lot hotter. This will cause the outer layers of the Sun to expand and swell. And as the Sun gets bigger, it is predicted that the outer layers of our star will envelope Mercury, Venus, Earth, and maybe Mars. I mean, it depends on what model you run as to whether Mars escapes this or not. And this expansion marks the beginning of our Sun's life as a red giant star. And during this phase, the Sun's core will fuse helium into carbon and oxygen. And this is usually where fusion stops. But some G-type stars are massive enough to fuse carbon. But that's about it. So, after helium is done, we have a core that's full of carbon and oxygen, and no more fusion is occurring to keep the star supported. And this is where the fun happens. After fusion ends, the outer layers disperse into a planetary nebula that looks a lot like this one. And the core, no longer being held up by fusion, collapses. The entire core of the star shrinks, and the remaining matter becomes so tightly packed together that there's no more room between the atoms themselves, and the electron shells hold everything up. And this is called electron degeneracy pressure. And it's what happens when the cores of stars up to 1.44 solar masses collapse. Now, this weight is important because this is the weight limit that electrons can hold things up at. So, over that amount, and the core collapses further into a neutron star where neutron degeneracy reigns. That means that the neutrons are basically keeping things from collapsing further. This means that all white dwarfs known have a mass that's no larger than 1.44 solar masses. And this is important for some things like type 1a supernovae, but that's a little bit of a different topic, and I'm digressing here. Now, one more interesting fun fact about white dwarfs: they don't shine, even though they are bright and hot. Since fusion has stopped, all they do is glow from the remaining heat left behind from the rather intense core collapse. I mean, they're still very hot, but they're not fusing. And this means that their light is kind of the same from star to star. So remember that point, because I'm going to come back to it in a minute. So that's how our Sun will die and how white dwarfs are formed. And getting back to what I already said, when our Sun expands in this process into a red giant, it will swallow up the inner planets out to at least Earth and maybe Mars. But something I've always wondered about is, what about the planets beyond Mars, like Jupiter, Saturn, Neptune, and so on? What happens to them when the sun turns into a jet red giant? Will they still be around? Well, theoretically, yes, but no one has seen anything like that yet. And that's where this research comes in. By systematically looking at 7,000 white dwarf stars observed by the Sloan Digital Sky Survey, using instruments which measure their spectra, astronomers using the Very Large Telescope found one of them that didn't look like all the others. And as you can imagine, when you've seen one stellar remnant, you've pretty much seen them all. I mean, they have basically the same mass, they're made up of the same stuff, and remember that point about their spectra I told you to remember? Again, they're all pretty much the same. I mean, they'll vary maybe just a little bit depending on whether a large, medium, or small mass G star made it. But for stars like our sun, the spectra among white dwarfs, pretty similar. So when they saw this one weird one, they scratched their heads and tried to figure out what was going on here. Where's this hydrogen, oxygen, and sulfur coming from? So they puzzled their puzzlers for a few weeks, and then they said, hey, wait a minute. These are elements that are found in deep atmospheric layers of icy giant planets like Neptune and Uranus. So if such a planet were orbiting close to a hot white dwarf star, then the extreme ultraviolet radiation from the star would strip away its outer layers, and some of this stripped gas would swirl into a disk, itself accreting onto the white dwarf. So this, they reasoned with their reasoners, sorry, I've been watching The Grinch, must be what's going on around this particular white dwarf known as WDJ0914 plus 1914. They've observed the first evaporating planet orbiting around a white dwarf. And it stands to reason that something like this could happen to our planets when our star dies. This white dwarf is hot with a temperature of blistering 28,000 degrees Celsius, which is 5 times the sun's temperature. The planet is icy and large, at least twice as large as the star. And since it orbits the hot white dwarf at close range, its orbit is just 10 days, then the high energy photons from the star are gradually blowing away the planet's atmosphere. Most of the gas escapes, but some of it is pulled back into a disk that's swirling into the star at a rate of 3,000 tons per second. And it is this disk that makes the otherwise hidden Neptune-like planet visible to the X-Shooter instrument on the Very Large Telescope. I'm sorry, but that's just really cool. Now, one weird thing that's going on here, though, is... Should have caught that in the writing part. Sorry, guys. According to the researchers, so one thing that is going on here, though, is, according to the researchers, the exoplanet orbits the white dwarf at only a distance of about 10 million kilometers. And this would have been deep inside the red giant when it was forming, so it probably wasn't there when the star expanded. The unusual position of the planet now implies that at some point after the host star became a white dwarf and shed its outer layers, the planet somehow moved closer to it. It couldn't have been there when the giant expanded. Now, the astronomers believe that this new orbit could be the result of gravitational interactions with other planets in the solar system, meaning that more than one planet may have survived this host star's violent transition. But we don't know for sure. All they can see right now is the spectra, and they can't make out the planets themselves. They can't see them directly. So more study on maybe the wobble of the white dwarf using the radial velocity method may be needed to see if there are in fact any more planets out there. But right now, they are only inferring the existence of this one Neptune-sized exoplanet and nothing else. Now, I've said this before, and I will say it again, and maybe many more times. It's remarkable the amount of information that can be gleaned from a few carefully measured photons from outer space. That astronomers can learn so much from so little makes me really excited about some of the future telescopes that are coming online that will show us these wonders directly. No more inferring things, let's look directly at these exoplanets. I can't wait. I want to thank Wova Globes for sponsoring this episode of Space Fan News. If you're looking for a cool gift for the space fan in your house, I think these are a great choice. These globes are powered by ambient light, and they require no cords of any kind, And I think they're very beautiful, and they're also quite durable. They have all sorts of planets, they have the moon, as well as Earth globes. So please check them out. And I want to remind you that when you do that, when you check out the sponsors of the Deep Astronomy episodes, you're actually helping me produce more content. So thank you for giving them a shot. And the link below, it's not an affiliate link. It just takes you to their webpage. And thanks also to my Deep Astronomy Patreon patrons who keep the lights on here and ensure new episodes are made each week. And thanks to all of you for watching. And as always, keep looking up.